So in this video, I'm going to show you how to do the problem numbers 14 through 19, where we start with a factored form of a polynomial function, and we're supposed to analyze the graph of the function. So we'll start here with number 14, analyzing the graph here. We're in, by the way, Unit 2b LO2, which is dealing with polynomial functions, graphing them and finding their degree and things like that. But for the first part here, determining the end behavior, we want to find a function that resembles this function here for large values of x. In other words, basically all we have to do is take your x squared and then multiply it by x to the first power, and we get x to the third power. So the end behavior model would be y equals x to the third power. And so we know that y equals x to the third power looks like that. And describing the end behavior, which we'll talk about in class, we would say as x approaches infinity, y also approaches infinity. And what this means is that as x goes to the right, as x moves to the right, y goes up. Okay? And then the next part would be, we would say as x moves left, y, so as x moves left along the x-axis, the y values are getting smaller. So as x moves left, y goes down. And down for y is negative infinity. Left for x is also negative infinity. So as we're saying really as x moves left, or as x goes, I should use the same word, moves left, y goes down. And so that's how we describe the end behavior. Finding x and y intercepts. First, let's find the x-intercepts. If we find the x-intercepts, we just let y equal 0. And setting y equal to 0, we get 0 equals x squared times x plus 2. Setting each factor equal to 0, we get x equals 0 and x equals negative 2. And then the y-intercept would be when x is equal to 0, and then so we already see that when x equals 0, y equals 0. So the y-intercept is also 0, 0. And so we have an x-intercept of 0, 0, as well as negative 2, comma 0. Let's see. Determine whether the graph crosses or touches the x-axis at each intercept. So we can write that right here. At the 0, 0, what would happen is since x equals 0 is a 0, then and x is being squared, so x equals 0 is a 0 means that x minus 0, or just x, is a factor of the polynomial, and the factor is being squared, so we would say the multiplicity is 2, and if the multiplicity is 2, then the graph of the function touches the x-axis at 0, 0. And then we have the factor of x plus 2 that corresponds with the 0 of negative 2. And since this factor has an exponent of 1, the multiplicity of 1, we would say that the graph of the function crosses the x-axis at negative 2. So for number 14, we're just going to go ahead and take all the information that we just gathered and draw the graph of the function. We said that the end behavior looks like that, where the graph goes up from left to right. We know that the graph crosses the x-axis at negative 2. And so if we are going up from left to right, we have to start down here. We go up from left to right, we go through the x-axis at negative 2. And then we said that the graph touches the x-axis at 0. And so we're going to come down here and touch the x-axis and then go back up. And that's how we draw the graph.